All right. All right. Very good evening to everybody. This is Paul, NO0T, for the Front Range 6-meter group. And we're pleased to have today Alan, K0AV. He's going to give us a talk about how to track down RFI. And I've seen this presentation, and you guys will really enjoy it. So over to you, Alan, and let you take it from here. You should be able to share your screen.
Okay, let's see. Is it coming up? Do you see my screen?
Not yet.
Okay, so I have.
There you go.
How's that?
Yeah, I can see. You think I see two well, I see two slides.
Oh, I see what's going on. Okay, I'm sorry. I am sorry.
It's all right. Take your time.
Do you see the Zoom screen? Is that what you're seeing?
Roger, Roger.
Okay. Why is it? I'm so sorry.
All right, I just go to slideshow or play, I guess.
Oh, damn it. Well, let's see. There's some kind of a setting. Yeah, we'll take care of that.
All right, I got the clock at the top.
Well,
okay. That looks more like it.
does it say current slide?
Roger that.
Well, that tells you how many I've got, but most of them are pictures and it's going to move fast. So don't worry about 49 slides.
I'll hang on to my hat.
Go to the next slide.
I will.
Next picture.
Yeah, I will. Okay, anyway.
W4DEX, W4ZST, sounded good down here tonight, Dex. Good.
My name's Alan, and my call is K0 Alpha Victor. I've been licensed since 1960. And I'm not a technical person, so I'm not an engineer. You know, I just got frustrated with noise and started paying attention to what I could do. And at the end of the talk, I'll give you a lot of sources. And I've weeded through many of them. I've curated essentially any information you're going to need and sources, and I'll tell you how to use them so you don't waste a lot of time when you have a problem. Main thing is to know that it's not magic, it's just physics. And for you guys that are engineers, you don't understand what I'm talking about, but for those who aren't, it gets to be a lot of hocus pocus sometimes with radio things for some of us. And it's just the thing to remember is that someplace, somewhere is a source that is generating the RFI. And I'm showing you this slide mostly to say two things. One, I'm mostly a contest operator, SO2R. Can you see my cursor? Is my cursor showing up?
Roger.
Yes.
Okay. This is a P3 pan adapter, and it has an external SVGA card in it. So it displays up here. So I spend a lot of time watching the noise floor and paying attention to what's going on. So that's part of it. So what I'm going to talk about is some stuff, but I'm not going to talk about other stuff. In other words, let's say what I'm not going to talk about. I'm not going to talk about how to cure the RFI. We're going to talk about how to find it. because that's the main thing you've got to do. And how to find it is essentially a troubleshooting process. So the goal is to find the source that's bothering your radio and not find everything that might be generating some RFI in your neighborhood or within your house. If it's not bothering your radio, don't waste your time, because it's not a problem for you. There's many, many sources. Wall warts are a great example. You could take a sniffer and go around and find all kinds of stuff, but you'd be wasting your time. You want to peel your way down from the top source down to the lower levels. Anyway, we're going to talk about the troubleshooting process, pitfalls to avoid, and there's so many of them are psychological. We're going to talk about the tools to use, receivers for hunting RFI, what the options are, and what my recommendations would be. It's not the only way to do it, but if you're just looking for a clear path to being able to get a reasonable receiver for doing the work, I'll have some specific recommendations. Same for antennas. I've been through a few iterations lately, and there's been some really interesting changes in the last 2 years. Well, 2.5 years now, which are essentially game changers. We're going to locate the source of the RFI. I'm going to talk to you about a case study, a personal one with a successful outcome. What's the point of telling you about a problem I have that doesn't have a successful outcome? So anyway, years-long RFI problem, multiple sources, all very similar. Anyway, it got solved. And then we're going to talk about the best resources. So the problem is, and this is fundamental, but let's start here. It's about signal to noise ratio and inability to hear weaker signals. And it's like being in a baseball game. You're in a quiet stadium before all the fans get there. And as people come in, it gets to be, you can't, at first you can talk to somebody 10 rows away in a normal voice. And as things get going, you can't even hear the person next to you. So that's the signal to noise ratio changing. Number of RFI sources in our neighborhoods and our areas are increasing. Population congestion, power lines getting, in my case, getting older, deteriorating, becoming more prevalent. And then there's more and more microprocessor devices. And then, of course, arrays of solar panels with their inverters and controllers and stuff. Anyway, it is really getting to be quite a burden on our hobby. So let's not think that we're alone as hams, because we have other people that have RFI problems too. You got your cellular telephone industry. They have RFI problems that they have to go out and search out and locate, just like we do. Dispatch centers, satellite links, and satellites among themselves up in space, they have problems, and they take quite a while to sort out. Military receiving sites. There's a wonderful pair of books that I'll recommend at the end if you want to take a really deep dive into this stuff. A study done by a team of naval researchers looking at 20 receiving sites, HF receiving sites around the world that receive signals for the US Navy and all the things they go through. It's really quite something. There's some links, I'll give you to that. Air traffic control. Anyway, we're not alone in the fight. Again, still kind of a fundamental, how to improve the signal to noise ratio. Increase the signal strength by getting better locations, higher gain antennas. And the focus of what we're talking about is decreasing the noise. You can do that by using directional antennas, but locating RFI sources and eliminating the sources. So, hunting. This is not a one-time deal. This is like weeding your garden. This is periodic maintenance. We have lots of periodic maintenance things we do on our cars and our shacks and our rotators, everything, you know, so it's not a new thing for us, but just view it that way. Here's a garden, like weeding a garden, and there it is after it got weeded. Multiple sources are common. And one of the tricks here is to hunt them one at a time. Try to identify them. If you're going to listen for characteristics, you know, get some kind of a way of staying focused on one at a time, and then peel them back like layers on an onion. And I'm going to show you now a long list of layers in my immediate area. These are, each one is a specific case that I found from this very location. There was a refrigerator that was on 80 meters and 40 meters, a furnace, which had some kind of variable speed motor on it. That took quite a while. A Wi-Fi extender, which took me a while because I'd forgotten that I'd even put this thing in. It was just temporary, but I left it in. Computer power supplies are well known. Computer monitors can give off all kinds of garbage. Garage door opener, shop lights. Every one of these is something. And many of them ended up having ferrite cores put on them. Solar array next door. My neighbor's Wi-Fi router. A touch lamp. The big case I'm going to talk to you about is a defective power line hardware. I had a defective lightning arrestor, which was a quarter mile away, and that took a while to get it fixed, get it located and get it fixed. It was a big thing. Grow lights is another one. Aquarium lights. Let's see, there's some others I can ad lib, but I'll just tell you there's lots of them, and every one of these is a layer of the onion that got peeled off, got cured one at a time. And so now I'm almost completely clear. I've got one that's just developed in the last month, which I'll get fixed, I'm sure. Okay, tools of the trade. First tool is your head, your brain. And it's having the right attitude that it is just physics. You will find it. You will find it. There's not going to be a mystery about it. You're going to locate it first. Stay focused. And I suggest giving your brain an assist by using an RFI log. In other words, write everything down, just like a doctor. You're getting symptoms, you know you got noise, that's your symptom. And you start poking around, you notice when it's on, write that down. Is it constant? Does it fluctuate with the wind? I'll show you an example of a RFI log in a couple of minutes here. Record all those external things, because if you can determine that it's outside, like if it gets really windy and it starts crackling and everything, then you know it's outdoors, and that's part of it. If it comes and goes with, I saw a post on the RFI reflector this afternoon. Guy was wondering about LED lights, the street lights. Well, if you know, and I didn't put that on my list. I had a street light. I don't think I put that on my list. A street light that it would give RFI pretty bad when it was turning on and off. When turning on, it would have firing up problems and get all active. Anyway, moving on to tools of the trade. Receivers. It's very helpful to have a portable HF receiver that has an external antenna jack so that you can hook up some of the various antennas that are available for direction finding. But I've got a specific, very relatively cheap example of something you can use. and an SDR receiver. Those are a little more expensive, and the software is free, but usually for those. They're very helpful because then you can see. Well, I'll explain what that is and how that works better. Antennas, something for HF, or VHF and UHF, some attenuators, and a preamp for if you're going to use a loop for direction finding. Okay, there's the brain, and part of that is avoiding mental traps. To me, this is the essence of what we're talking about tonight. I've already touched on the first one. Understand, convince yourself, know that you're going to beat this thing. It's doable. Somewhere there is a source emitting a signal causing your elevated noise floor. You just need to isolate it, find out when it comes on. You don't need to know what it is at first. You don't really need to know that yet. You need to know where it is. And this doesn't speak, like I said, it doesn't speak to everyone, but avoid believing in magic. I mean, it's just something that somehow you can get blocked about it. It's not doable. Yes, it is. You can fix it. You can find it. Keep an open mind. I've noticed well, I think this is human nature. I was going to say it's engineers do this a lot, but I think we all want to try to figure it out, get an explanation as soon as possible. And we come up with a theory, we get it pictured in our mind that this is it, and it's got to be it. And just stay loose, okay? Just keep doing the direction finding, keep an open mind, don't focus too early on a theory. And like I just said, don't waste much time on what it is. I think part of the problem is we're all, especially to the extent that any of us are retired, we can go down these rabbit holes and go into thinking, oh, it could be this, and what do I need? Then I have to learn all about this device. Well, maybe it's not even that device, so why spend the time? What you want to do is shorten the timeline to the ultimate fix. Anyway, find out where it is. One thing I've noticed a lot, I've seen it quite a bit on the RFI reflector, which I'll give you the site to those for those who don't have it already. Don't waste time getting angry at the Chinese manufacturers that import this crap, the utility for charging us money for electricity and then not giving us perfectly RFI free environment. Don't get mad at the FCC. I mean, it's all probably true what you're thinking and feeling, but it's not going anywhere. You're not going to convince a manufacturer in China to come and reclaim their device. I know it sounds silly when I say that, but there are people that spend a lot of energy on this stuff. And if your goal is to fix your noise problem, that's a waste of time. I mean, if you've got a lot of extra time, I suppose you can do it, but it's a waste of energy. Stay focused on finding the source that's causing your elevated noise floor. Like I said at the very beginning, don't waste time trying to sniff out every possible anything that generates noise on your property or in your neighborhood. Just get what's getting to your antenna and into your receiver on the frequencies that you want to use. And plan on getting used to walking around the neighborhood with the DF loop. That can be a barrier, it can be a friction point for people getting out and getting it done. I can tell you that at first I would just go out at night. You know, if the sun was going down, I'd take a radio and put it in my pocket. Maybe I'm shyer than most, but depending on your neighborhood, sometimes you have to walk around with something that's kind of big. My neighbors are now used to it. I live in a neighborhood with 100 by 150 foot lot, a third of an acre lot in a subdivision. So just get to know your neighbors, let them know that you're a little odd sometimes, maybe, but just do it. Okay. You may feel a little strange at first, but you don't have to wear a tinfoil hat, but get used to it. Before you go out around the neighborhood looking for stuff, do the power off at home test. And that starts with getting something to run your radio, probably a 12 volt, 13 volt battery. Just, the equipment that you're being bothered on, and perhaps the antenna switches so that everything is active. But you've got to do this. This is the first thing I've heard, not from personal experience, but I've heard that of the RFI cases that have been referred to radio club, RFI committees, fully 80% of the cases are from Ham's own house. And I've had this confirmed by talking to utility people as well. So, and be happy. Be happy if it is in your house, because it's something you can take care of really quickly, or perhaps get to the bottom of it. Anyway, set it up so you can run on battery, and then see what happens when the noise floor when your home power is shut off. I suggest taking notes and a photo of a scope if you've got a pan adapter or an SDR that you can be looking at. Be sure that the battery chargers and uninterruptible power supplies are shut off. Shut it off at the main service panel as it enters the house. Practical consideration, probably domestically diplomatic, is do it when the family's not home. You'd be surprised how unsettling it is and how upset people get, again, from experience. If you start shutting off the power to the house, then all the devices start to beep and blah, 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 and practice. And I've got it down so that I can shut off my power, do my tests, and get back and get all the clocks and devices reset within 2.5 minutes. Your mileage may vary on that, but you become adept at it. It works. And then you learn a lot. This is an SDR photograph of, let's see, this is all of these lines are, see if I can say this. Down here where my cursor is going across is with the power off. And then I turned the power back on, and this is all from the refrigerator, as I recall. See how there's quite a bit of noise. That was cured with 2 common mode chokes on the power cord. This was a separate case. This sounded like white noise, but then when I took the SDR, see the spread up here? This is 3.507.8. So this is like 0.5 kilohertz right here, this whole thing. These, when you listen to it, not spread out, these were all together. And it wasn't until I spread it out, I realized they were all lines. And then I could tell that I had to know, I just needed to know where it was, but that it was in my house and that it was a microprocessor. And then I took a sniffer with the SDR and walked around, and the closer I got to the refrigerator, the more I knew that's what it was, and got it fixed. Here's a sniffer. this is can go on the antenna into the radio, the shortwave receiver I'm going to show you, or on VHF. I use, is this UHF or VHF? If it's 440, I put it onto the 440. So whatever that is, 440 band, I use that and I stick it on there, sniff a lot around a lot of places. Okay, a good thing to do, to be situationally aware, you need to, I think it's helpful to do a noise survey and do long-term monitoring. Just keep track of stuff. You can set up an SDR with its software and let it run for a really long time. Few days if you want, preferably when the band is not open, because you don't want stuff coming in on the long haul. You just want to listen and watch. Here are the items that I record in my RFI log. I use a Word document or a Apple Note, or just any kind of a little text thing. I didn't put in here the date and the time, but put down your noise floor reading, hopefully on a pan adapter or an SDR, or an minimum at least SDR, S meter readings. Keep the mode consistent, keep the bandwidth consistent, keep the same beam heading, and keep track of when the noise is active. And with phones now like this, we can take photos of the display. I make a reference in the log of when I took it. And then you can make some notes about characteristics. One other thing I do is, it seems like when I'm doing this and I see something and I start to think about it, every time I get some more information, my brain gets really active. And that's usually is the best your brain is going to be in terms of sorting this out. And many times it comes up with, well, what am I going to do next? Well, put down what you're going to do next, so that you can just keep making progress on this and not getting mixed up with what you thought you remembered and all that sort of stuff. So I keep a perpetual record of observations and things like that, the symptoms and what I'm going to do. So here's an example. This is out of Apple Notes. Okay, so I went out and I had an SDR out in the backyard and I made notes about what it looked like. Here's a photo reference. So if I wanted to, I could go back and replicate what this problem was. I could set everything up exactly the way it was. I had the SDR with a 9 megahertz bandwidth. Hold on. No, I was at 9 megahertz and I had a bandwidth of 8 megahertz. So I had a big spread of what I was watching. Fortunately for me, I couldn't duplicate it 3 days later. So whatever it was, I don't need to know that. I don't know. And then my plan was, okay, in spite of this 9 megahertz thing that I had found, my plan was to stay focused on the power line noise. I thought it was apparent power line noise. And I made a note, and I had noted there was a 15 dB jump in the power line noise the night before. So that I stayed focused on. Okay, receivers for hunting RFI. You want to be ready to tackle things from HF to UHF. A key thing, and this is part of a 6 meter application here, as you get closer to the source, the VHF and UHF is much better as you get in close, especially in power line noise. You want something that's portable, battery operated. I already mentioned external antenna jack. not FM, AM, SSB, or CW. Something with a strength indicator. That's very important when you're DFing. You want to be able to find where a null or a peak is. And then I've seen many cases where as you get in closer and closer and closer, it gets so strong, the noise is so strong that it overloads, and it really makes it difficult. Your goal is to keep the S meter at mid scale because it'll be more accurate. So this is my personal favorite. This is from their ad, so it shows an FM station, but you can see up here, there's an S meter. On this end here is an antenna jack. You can make this run, let's see, it has air band, so that'll take you AM up to like 130 megahertz. You can run this up to like 30 megahertz for sideband. Down low, I think 160 if you want to get really low. So this helps a lot. When you put the antenna jack in, you plug that in, it disconnects this thing, this other deal. And you can be SSB, but this has a BFO right here. So if you want to listen to CW, you can. Those are side features. The main thing is that you're going to be able to go out in the field and use the direction finding antennas. This is the FT817. This is really very cool radio for a lot of things. You probably already know that from being UHF people, but this has got HF and the higher bands. So I use it at 440. Okay, so this is, I have a little difficulty myself trying to figure out this slide, but this came from the Naval Postgraduate School study that I referenced earlier. I think what they're trying to show, they're making the point that if you have power line noise, see here's power line noise coming, I don't know, let's see. So from pole 1 and pole 2, but as you go up in frequency, your DFing becomes more localized, because one of the problems at the low frequencies, and here they're even talking down to 50 megahertz, but the higher you go, the more directionality you're going to get, the more localization you're going to be able to get. I can't explain it exactly other than what I just said, and this picture is what they try to use to illustrate that point. They make the same point. It really does work, because once you get closer in, then you switch over to UHF and zero in on it. And then you can try to locate it on the pole if that's what it is. You become more localized. Okay, antennas for direction finding. So use your beam when you're first finding what direction. This is common sense. You're going to point and try to locate where it's coming from, what direction. You can use a magnetic loop. Usually they need a preamp with them, and they're bidirectional. This is what I mentioned as a game changer, this portable flag loop, and I've got a picture of it and all that, was developed and was the subject of a QST article March of 21. The guy homebrewed it. The great thing is that it's unidirectional and it's broadband. In other words, you could be having a problem in your band, but if you got to consider that the source might actually be coming from outside the band and spilling over somehow on some kind of big sidebands or something. It's some weird stuff out there. So it's great to have a broadband antenna. And broadband, I mean like 160 to 30 megahertz. I'll show you where you can get some, if this is something of interest, then you can get some data on it. He's got curves and all that stuff. It was designed by a guy who's a real engineer. And then a portable beam. I use a 7-element 440 UHF beam, which is helpful. So that's my beam. And I, do what you would do. That is turn it around until you can get a general idea where it's coming from and make a recording in your log about that. My beam is a stepper, the bottom one. And that's helpful because then I can use the reverse feature to just kind of confirm that I'm on the right side of it, so on. This is, I don't use this all the time, but it can be handy. It's nice to have a bunch of stuff in your toolbox here. This is a National RF HFDF mag loop. It's sold commercially. I think a guy could build one. This is a mag loop, and it has a preamp built in, and just above the cursor point is a knob to tune the preamp, so to peak it. And this is bidirectional, so you'd have to if you didn't have any idea where your noise was coming from, you'd need to move around and triangulate, go to some other place. This is just clamped in here on an old a video tripod. And then I'm coming down to SDR, one of the SDR plays, and I have a tablet PC that runs the SDR software, so I can be outside. I mean, I'd love to have a tough book or whatever they call those, made for police departments and outdoor use. I would love to have that, but I don't. This is a curve. This shows the null. I made this myself with that loop. So you see it's like a 60 dB there, and so let's just say 28 dB null as you turn it around. So and if you're going to do some nulling out in the field with something like that, and you haven't played with it much, take a signal generator or something that puts out a signal and play with it. With an SDR, you're going to need to go slowly. That's the nice thing about that tripod, is that it's fixed. You're not wildly swinging the thing around willy-nilly, but there's latency. So you need to go very slowly to give the SDR and its software and processing and everything a chance to catch up. So go very, very slowly and come back and then repeat it like any good experiment. You're going to want to have repeat it. So here's this guy that built this game changer. His name is Don Kirk, WD8DSB. And this was March of 21. He made that. That's his portable shortwave receiver. This is his, probably his preamp. This is unidirectional. So in other words, you don't have to go triangulate this. You can go find out what direction it's actually coming from. And I'll show you an example of how that worked on the first time. Again, broadbanded. They sell it as a kit from DX Engineering. This is one of their employees holding it. Whoops. That's their deal. It's a kit, but you can build it yourself if you want to. This is really cool. Even if you built it yourself, you might want to get something like this. This is their this is the preamp that's built in, and you switch that baby on. if you're going to be on low frequencies or you're in the area of AM broadcasting, they've got a filter for AM broadcast that can sometimes overpower these preamps. And then you've got a total of 30 dB of attenuation you can kick in there too, if you get in too close and it's overwhelming your receiver. This is the curve. Again, this is a null. So you null it. This is his slide from his measurement. He calls it a portable flag. Okay, so here's the first use that I put this portable flag to. There was a guy up in Custer County that had a pretty bad noise problem. I had a hunch I knew where it was coming from, but it could have been multiple power poles. I wasn't sure, but as an experiment, I connected the loop to the station receiver. I was outside with my tripod deal. I wasn't looking at where it was pointing. I was down at the ground. There was somebody inside watching the S meter. I had an attenuator on the preamp, got an accurate reading, just like I was saying, S meter at mid scale. I rotated very, very, very slowly. And I think I was watching on the SDR. I nulled it. I repeated it twice, and I finally looked up, and that's where I was looking. See, it's looking right down at that power pole. And I don't think it could be any more accurate than that. And that's where I was. That's where the power pole is. You can see the shadow, 475 feet away. And the power company came and fixed it. But we were confirming it. So this is a friend of mine holding, 7 elements. There's more out here, and it's got an FT 817 right there. So this is my power line example. It turned out I had 4 separate RFI sources with 10 to 15 dB of extra noise floor. And it was intermittent. It would come and go. Some of them would be bad. Sometimes it seemed like they'd all be on, but you could never predict. So I couldn't, when I thought I knew when it was going to be off, because it was cold weather or something like that, I plan on doing a contest, and I'd be about, one I can remember in particular, it was about 45 minutes into it. I couldn't hear anybody coming back to me after 45 minutes. It came up and got crazy. It was on all the different HF bands. I watched and finally figured out the different directions. I ID'd all the pole numbers, and I got the Colorado Springs utilities. I had them out multiple times. They tried to cure it piecemeal. They had one day they had 1 bucket truck out here and a guy lineman up poking around. It's helpful if you have a receiver with a speaker on it that's portable and a loop or something, or a 817 and a UHF beam. If you're down on the ground and you can have the noise going, and they start poking around, then they can tell you, they can figure out what component it is. That's a helpful thing to have. Anyway, they tried to cure it piecemeal. They came out another time with 2 bucket trucks and a couple of crews, and another engineer, 2 engineers. And they finally looked at each other and said, well, these are just too old. We're going to have to replace these damn things. All the hardware and all the 4 poles in my alley. And so my message is, don't lose hope. So here's the old pole. This is what they all look like. Some were worse than this. And here's the new ones. See, the linemen are up there putting in the new ones, putting all the hardware in. And there's a 4th one down this other way. To be sure, I was, the results, I measured the noise floor the day before. And then I measured the day after. And all four of the intermittent sources along the line were gone. And the noise floor dropped. Not only did the 10 to 15 dB intermittent sources go away, there was an additional 5 dBm drop beyond my best ever day. Let's talk about software-defined radios and receivers. I think everybody probably knows this already, but just to be sure. Just like a spectrum analyzer, helpful to have the waterfall underneath. And one good thing about this that you don't get with these other, just listening to a shortwave receiver, is that you can look at a wide swath of stuff, especially if you're using that broadband antenna. You're able to watch a lot of stuff going on. It's just nice to know what's going on around you. So here is, how much am I looking at here? Probably 50 kcs, 50 kilohertz on an SDR. I've got a lot of junk here from computer monitors mostly. And these lines are not all from different monitors, they're mostly one. I don't know what this yellow thing is. May have been a CW signal. I don't know. Doesn't look like it though. But these horizontal lines are power line noises. That's power line noise. So here's a block diagram of setting up an SDR. Anybody who's done it, it's nice and simple. Have an antenna, DF antenna, have your SDR receiver, go out to the computer and up to the display. Nice and simple. For me, the trick has been mostly making it portable. If you want to, I think it's important to make sure that what you're monitoring in the field is what you're monitoring in your station. So step one, start here, your normal receiver, your band scope or whatever, and then switch your SDR receiver into your antenna, your regular antenna, see if you can match it up, compare the signatures, and then switch over and confirm again, and then go into the field. This is the one I have, kind of spendy, but it makes me feel better to have a metal case instead of plastic. Software, I'm not going to give you the big rundown on all the software. I'm just saying what works well for me and why. This SDR console, it's free. I found the website to be a bit confusing, but it has a feature called signal history, which I don't think the others do. The other softwares do. It's nice to be able to turn it on and let it run for a long period of time, because if you have an intermittent source, it tells you a lot. But those SDR Sharp and SDR Uno are the other ones. And I'm not going to talk about, well, I'll sometimes do this. Passive intermodulation. Sometimes you can find a source that isn't by something you would expect. It can be poorly soldered joints or something like that, but often it's a result of transmitting. I won't go into that too much. Roofs and gutters, they can be picking up a broadcast station and retransmitting something. So just be alert if you can get something located that looks like a junction, maybe a fence line or something. That'll help you a lot. Okay, resources. The ARRL website has a RFI page. A lot of great resources there. I want to talk about this RFI reflector. This has been an absolute wealth of information. The archives go back 22 years. you can go back and search the archives. It's I'm not sure it's showing up very well, but contesting.com. The moderator is K3LR, who is got probably now has one of the quietest locations you can imagine. There's a lot of multi operating. You can go back in the archives and search for answers. And I'd say better than 75% of the time, I can get an answer. For instance, I mentioned I had a furnace problem. I put the make and model in, and I came out with all the answers I needed. You know, a lot of reflectors have experts, so-called experts, and then there's experts. This list has a very high signal to noise ratio. These people that are on there, many of them they work for power utilities. They're engineers, and they are in the business of locating RFI. So there are some real experts. And it saves you so much time, and you get so much insight. In terms of locating RFI and kind of the process, this WD8DSB has a YouTube channel where you see him start. He says, so-and-so gave me a call, says he's having this problem on 15 meters. I went out with this antenna and all this stuff, and I went out and here's what I did. And here you can see me do it, and you can listen to what it sounds like. And then as we get closer, and I used this UHF or whatever he did. And you go through the process. So you kind of get to solve a lot of RFI locating problems with him. Another high yield place for information is K9YC's. He's got an article called Killing RX Noise. He gave a talk at Visalia, and that's it. If you want to try to figure out, well, I want to know what it is before I find out where it is, which I'm preaching against, but if that's what you want to do, you want to go down that rabbit hole. This guy, NK7Z, has a bunch of RFI snapshots and what it looks like, and some, I think, even what it sounds like. And then, as I alluded to before, this Naval Postgraduate School RFI handbooks, and they're linked from the ARRL RFI webpage that I mentioned at the top. This is very cool because it was done, all these guys, the co-authors are all hams, but they were under contract for the signal to noise enhancement program. I mean, isn't that what we want? Signal to noise enhancement? That's what we're doing. So they surveyed 20 Navy radio receiving sites around the world. And there's 2 books, 2 sites. They're big, large PDF reports that you can download and read. If you want to nerd out on this stuff, this is a place. Now, it's a little dated now, but I highly recommend it. But like I say up here at the top, it's all right here. So you're only as good as your sources. And where are we? Have I stopped sharing? Yep.
Yeah, you can just stop sharing.
I'm sorry it took so long. I now see it was 58 minutes. I got into it tonight. Sorry.
Yeah, hey, we really appreciate your helping us out here tonight, because that's I've seen it a couple of times, and every time I get something new from it. So it's going to be on my favorites list to keep watching, and I really appreciate you spending the time with us.
Sure.
I think you indicated, did you say you're going to give me a copy of the slides for our group in our archives, or?
I can, yeah. Yeah, I'm working on a Mac, so that was in Keynote, but I'll turn it into a PowerPoint and send it.
No, just a PDF is all I need.
Oh, PDF, okay.
Yeah, just a PDF, because I don't have room for PowerPoints on the group web, the group.io site.
Okay.
But that way people will know it's under the files section. They can get a hold of it and with all those references, because there's a ton of information there, which is just remarkable. And I love that antenna that just nulled out and showed you right exactly where this pole was that gives you the noise. I'm fortunate now. I've moved my station from downtown Denver to Haswell, and my nearest neighbor is 3 miles away. And I have a very quiet site. But even though I have a very quiet site, I can still pick up noise on the horizon from, like far away stuff. And I can hear a thunderstorm in Alabama anytime. And I can tell you exactly where it is. Anyway, I'm going to open it up to questions, guys, because I'm sure you must have a few questions. So why don't you do that? And one more thing, I got to get up really early tomorrow morning. So what I'm going to do is I'm going to let the Zoom run until you guys are, and you guys can keep asking questions over and over again, and then I'll turn it off later on. So anyways, why don't you go ahead there, Bob, ZST, you had a question. I saw your hand. I'm sorry, you have to unmute. You have to just unmute or hit your space bar. It's push to talk. Space bar.
Well, the space bar didn't work.
No, well, maybe it's your computer.
I clicked down on the thing. So
never mind.
anyway, for Alan, any particular hardware that is power pole hardware that is most suspect for noise problems?
I know that I have seen, let's see, I'll give you the two answers. One came from some of the linemen that have been out here. And they said that the most common source for noise problems that they've found over the years has been ground wires and their staples on the side of the pole. So that's one. The problems that I had were just aging, and they were up there and they were looking at transformers and they couldn't tell if they'd been hit by lightning but they said I could see track marks. I remember one guy saying track marks of black and stuff. And then there's some comments on the RFI reflector there's two guys at least, but one comes to mind. If you did a search on the archives there, Kilo Bravo 4 Tango. He's a power utility guy. Maybe he goes, I'm not sure, but maybe he goes all over Florida or something. He's their RFI troubleshooter guy. And he's had a lot of great comments about things. When he comes into an area, because he doesn't he's not like me or you, where we've got a noise problem that we're listening to. He comes in on a complaint. So he comes rolling in his truck with multiple antennas and multiple receivers going at the same time, drives around the neighborhood, gets a feel for it. I'm going off on that. I just admire the work he's done and how knowledgeable the guy's become in what is, for us, many times seems like a unique situation.
Yeah, thanks. Yeah, well, I wish I had a guy that dedicated near me, but I think it's staples and ground wires are my problem. Just the opposite of yours. Mine started when they put 3 new poles real close to me with lots of switches and lightning arresters. But we're pretty sure it's the staples.
One of the benefits, I should say this in this talk, but I'll say it, is that one of the benefits from locating it and knowing where it is that they're not going to be, the utility is not going to be very responsive to you. They're not able to be as responsive to you if you haven't told them what power pole it is. If you give them the number and and say, I did this and I did that, and here's what it is, and here's how many dB it is. So I've got, at this point, until this guy leaves, and I hope he never retires, but I have a relationship with the guy, and I can call him up about somebody else's problem and say, this is where it is, this is what pole it is. And sometimes they'll just show up with the bucket truck instead of making another visit. So it shortens the timeline.
Thank you.
Any other questions? That's right. I appreciate very much you spending your time with us today, Alan. And I'm going to, like I said, I recorded this, and if you can email me the PDF file, then the guys will love to take a look at that, and they can download it themselves if they want from our IO site. So I'm going to let the guys go, and I'll say 73 to all the guys up there, and say Peter up there in Ottawa, and Mark. And
Bye, everybody.
So thanks again.
Thanks for having me. Appreciate it.
Thank you, Alan.
You betcha. Bye-bye.
Thank you. Thank you.
Thanks, Al.